Good evening, everyone. Welcome to the webinar. So we're going to look into certain tasks that we can do using Gen AI, okay? Preferably NLP tasks. So let's talk about sentiment analysis first. Sentiment analysis is basically classifying a particular text as a positive or a negative or a neutral sentiment, okay? This immensely helps when you're trying to go through a lot of reviews of products or on e-commerce platforms like Amazon, or when you're going through reviews of movies given on any OTT platforms. It helps you understand what is the sentiment behind it. Okay, let's begin with first. Let's start by installing the required Python packages. So we are basically using Hugging Face Transformers library for working with large language models and Accelerate. This will help us utilize the available hardware like GPUs. Okay. The -q flag here suppresses the output for a cleaner install. These libraries are essentially for leveraging transformer-based models for NLP tasks. But before I run the code, I'm just going to show you that it's always better to change your runtime on Google Colab to GPU, right, for faster instance. So once you do that, after that, we're importing these required libraries, all right? So from Transformers library, we're importing pipeline, auto tokenizer, and at the same time, we're also importing Torch. So these will manage our tensor computations. And we fix the manual seed, random seed using torch.manual seed 0 to ensure reproducibility. This way, if the model introduces any randomness during the generation, we can expect the same output on reruns. Then we define the model. Here we'll be using Falcon 7, which was trained on 7 billion parameters. Okay, this is a powerful instruction-tuned large language model built for the text generation tasks. And we use this auto tokenizer from pre-trained to load the appropriate tokenizer for this model. Finally, we're setting up the text generation pipeline, passing the model and tokenizer. Okay, for this, we specify torch data type, torch D type to use, and we have used here bfloat 16 for efficiency, for memory efficient floating point format. And device map we have set to the auto so that the pipeline intelligently uses CPU or GPU based on the availability of it, right? Okay. And then we're importing, so although we imported torch earlier, this cell is probably a safeguard to ensure the torch library is available in the current execution environment. And it's always a good practice to re-import key libraries if needed in the later cells, right? And you can get timed out of the session since you're using Google Colab GPU. So that can always be done. Okay, let's get into this depth of sentiment analysis now. Yeah. So basically you can see after checking the random seed for reproducibility, we're entering some prompt. And that prompt says that we're classifying, we're trying to classify basically whether, classify the text into either neutral, negative, or positive. And the text that we're giving here is the scenery was breathtaking and the music was unforgettable. The entire experience of the concert was nothing short of a magical. And we're trying to find out what the sentiment would be. It's trying to generate new sequences after that. And maximum tokens, we are trying to limit the number of tokens being generated to just 10. You can change this, you can manipulate it to 15, 20, 40, 100, how many ever tokens you wanted to generate. And printing these generated sentiments, classification results. And once you do run this, the positive sentiment is what it's returning, right? Because someone is actually appreciating the scenery of the music, okay, how amazing the music was. So it is recognizing the sentiment as positive. Let's check another example. So we can classify the sentiment of the text and main factors which are contributing towards it. Let's see. So the phone's battery life is terrible and the camera is disappointing. Overall, I'm very unhappy with this purchase. Let's say that there is a review written like this, and we need to understand what is the sentiment. And this time we are saying that, we have mentioned that maximum tokens to be generated as 100, because we also wanted to classify the sentiment and also talk about what are the main factors. What is the reason for that particular sentiment? If that sentiment is positive, what is the reason behind that? If the sentiment is negative, what is the reason behind that? We're trying to find that out. So that's why we have put that let's generate at least 100 tokens. It is reading this and it is giving me that the sentiment is negative. So someone has written a negative review over this. And the reason behind the negative review or factors which are contributing to this negative review are two things: poor battery life and disappointing camera quality. Right? So poor camera quality and battery life. This is what is contributing to this. That was about sentiment analysis, analyzing sentiments of particular product reviews. Okay. Let's now look at some other tasks like entity extraction again. Entity extraction, when we'll see the example and you'll try and understand. So let's say we have a prompt here, return a list of named entities in the text. This is the text, whichever are the entities, objects that we're talking about, okay, subject that is being talked about, we need to point that out. So the text says Mount Everest is the Earth's highest mountain above sea level, located in Mahalangur, Himachal, sub-range of Himalayas. And we want to find out what are the named entities in this. So we're mentioning that limiting the response length to just 15 tokens, okay? Return only the regenerated text instead of returning the entire text, okay? Maybe only the regenerated text we're restricting it to in a sequence. And it is really recognizing the entities that we're talking about. We're talking about Mount Everest, Earth, and the Himalayas, right? Let's see another example in the same entity recognition. So we are trying to return a list of named entities in the below text. This time the text is different. CRISPR Cas9 gene editing technology was heralded as a breakthrough in the field of genomics. So what are the entities that we're talking about? Again, we wanted to return only the name of the entities, and we're restricting the response length to just maximum 15 tokens. So the output that is giving me is we're talking about CRISPR Cas9 and then gene editing and genomics, right? So that's the kind of output it is giving me. And yeah, we can also do topic modeling on this data. Let's see what exactly topic modeling even means, right? So we looked at sentiment analysis, which is classifying the text into positive, negative, or neutral sense. Entity extraction, identifying what are the named entities from a given text. Topic modeling is to extract the main topic of a given text. What is the main topic? What is the text even talking about? Right? Just a gist of it. Okay. Let's look at topic modeling also. So there is a prompt here where we're saying extract the main topic from the given text. Text goes like this: as the digital age accelerates, the domain of cybersecurity is becoming increasingly paramount. The widespread deployment of internet-connected devices has led to a surge in potential points of exploitation, making it imperative for organizations to develop stringent security measures. With the advent of technologies such as the Internet of Things (IoT), artificial intelligence (AI), and cloud computing, the complexity of cyber attacks has risen, necessitating advanced defenses. The landscape of cyber threats continuously evolves, as do the tools and strategies to mitigate these risks, highlighting the ongoing arms race between cybercriminals and cybersecurity professionals. Okay, what exactly is the main topic of this particular text that is given here? We're trying to find out that. Again, restricting maximum tokens to maybe 15. You can change it. Like I said, you can manipulate it to 25 based on what you'd like. And we don't want to regenerate the old text, this entire text. We just want the answer. So we get the result here as the importance, the topic that this text is talking about is the importance of cybersecurity in digital age. So there you go, that's your output. all of these tasks that I'm showing you, right? Sentiment analysis, entity extraction, topic modeling, creative writing, text summarization, dialogue generation, all of these tasks are being performed by the LLM, the first model that we fetched from our Hugging Face, which is TII Falcon, which was Falcon Instruct basically, which was trained on 7 billion parameters. All right, let's move ahead. It also helps in creative writing. Let's see the prompt we're using for creative writing. So here we have set a prompt that write a poem about the Northern Lights. So it's going to creatively generate a poem about Northern Lights. And once we mention maximum tokens as 50, it's going to generate maximum of 50 words. I can increase these tokens to 150 and it can start generating a poem of 150 words, so on and so forth, right? The sky is the limit. You can keep experimenting. Let's see the poem here. The poem says a celestial ballet, a midnight show, a cosmic dance, a shimmering glow, the aurora, a dazzling array, a beauty story, a northern light display. In the night sky, a magical glow. So you can keep increasing the maximum tokens it is supposed to generate and maybe increase the length of the poem which, as you wish. Not just a poem, you can write a paragraph, maybe you can actually give it a particular story that you're writing about, and maybe it will generate the next few lines of the story, next few paragraphs of the story. All of this also can be done. Okay. Now we'll also look into text summarization. Text summarization is nothing but summarizing a long text into concise version. Basically creating a concise version of a elaborated text. Okay, let's look at this example. So here again, for reproducibility, we're fixing a random seed and we're giving a prompt like this. Renewable energy sources like solar and wind power are essential for combating climate change. They provide clean, inexhaustible energy that reduces reliance on fossil fuels, which are major contributors to global warming and environmental degradation. Transitioning to renewable energy not only helps in reducing carbon emissions, but also promotes energy independence and supports sustainable development. Governments and businesses worldwide are investing in renewable energy technologies to secure a greener future. Write a summary of the above text, and I need to get the summary. So we're trying to extract summary, maybe the shortest length possible, only 30 tokens that we wanted to generate. And top underscore k, this is a parameter that we're setting here. Sample from the topmost and likely tokens. So whenever it's generating new tokens, to keep it concise, to keep the probability of the next token as maximum, we're keeping this top underscore k parameters as 10. Okay, let's see how it has summarized this huge text for us. So the output that it's giving me is renewable energy sources like solar and wind power are vital in combating the climate change. These sources provide clean and inexhaustible energy, reducing the reliance. Okay. Let's see another example. Here we're mentioning a few more things. We, instead of the same text was given here, but instead of saying write a summary, okay, write a summary of the above text, here I'm giving a prompt saying that write a factual summary of the above text without adding any new information. So basically you're preventing it from doing any hallucinations, going into any hallucinations, right? Let's look at that. How did we try and prevent those hallucinations? Very important thing to understand is we are setting top underscore k parameter to 0 here. And this is going to magically change my output. It basically removes the sampling parameter to focus on deterministic outputs. Let's see. So the text discusses, the summary goes like this. A maximum 30 tokens is what we restricted the summary length to. So the output says the text discusses the importance of renewable energy sources like solar and wind power in combating climate change and promoting energy dependence. So this is the summary of this above text. All right. Then we have dialogue generation. Okay. Dialogue generation, as it suggests, we are generating conversations based on some sort of prompt. Okay. Let's look at this example as well. So when it comes to dialogue generation, we're writing a prompt like this. The following is a conversation about benefits of renewable energy. So there are two people who are basically conversing about benefits of renewable energy. So there's person A who says, why do you think renewable energy is important? And what is going to be the dialogue of person B? Could be anything, positive conversation, negative conversation. It's on the LLM to imagine and generate the tokens. We're restricting this to 50 tokens, basically allowing for a longer response in order to facilitate a more natural conversation. And we're enabling sampling for more valid, varied, and natural dialogues. And again, to broaden the sampling pool and to increase the creativity of tokens, we are setting this top underscore K parameter as 50. And I've introduced another parameter here called temperature. So temperature can be between 0 to 1. We are setting a temperature of 0.9, which is almost clear to 1, near to 1 value. Higher temperature will allow for more diverse responses. Okay, it will start hallucinating more, imagining more, and give you diverse response. Okay, let's see the conversation between them. So the person B says, well, it reduces our reliance on finite resources like fossil fuels and helps us create more sustainable future. It's also more cost effective in the long run. And then person A again continues and says, that's true. It's interesting how. So the moment you increase these number of tokens, maybe make it 200, the conversation starts increasing between them, right? The kind of dialogues, the words being generated in the dialogues will also increase. Let's look at another example. So we can prompt a chatbot saying, the following is a customer service conversation for a sustainable energy company. So there is a sustainable energy company and customer service executives are having some sort of conversation with the customer or with the chatbot. The customer says, I'm interested in switching to solar panels. What should I know? And next, we need to generate what is going to be the response of the chatbot. Again, I'm taking the same kind of parameters for this in the pipeline. So maximum tokens, 100. A longer response, more detailed response because we're explaining something to a customer. Then enable sampling so that the dialogue can be varied, right? It can have more imagination. Top underscore K also, I'm putting 40. Temperature, again, a little bit on the higher side only, so that the moderate temperature for coherent yet varied responses. So I wanted to diversify its thinking, but not to a completely irrelevant sense. So we are keeping the temperature parameter as 0.8. And we want to generate these dialogues in a sequence. Let's look at the dialogue. So about the solar panel, the customer said, I'm interested in switching to solar panels. What should I even know? And chatbot is replying or giving a response that, hi, switching to solar panels is a great decision. You'll be reducing your carbon footprint and saving money on your energy bills. The customer responds, that sounds great. What are the benefits of switching to solar panels? Chatbot again replies, with solar panels, you will be able to generate a clean renewable energy from sunlight, reducing your reliance on the traditional electricity resources. This can also lead to a lower energy bills over time. So it is pointing out the benefits of that. The customer says, how much can I expect to save? Exactly how much money are you talking about? How much can I save? The chatbot can go on with the response. If I want to increase the length of this conversation, I can switch over from maximum tokens 100 to 500, manipulate so on and so forth, all these parameters, and I can end up with a good result. Let's see another example of this dialogue generation. Okay, we've given a prompt here. We're giving the description saying this principle states that the energy cannot be created or destroyed, only transformed from one form to the other. Principle says, the principle of this is basically conservation of energy. Description, again, every action has an equal and opposite reaction. What is going to be the principle behind it, right? Okay, this will generate a conversation response. So again, maximum tokens I'm giving as 8 to limit the response length, maybe not a varied and detailed response. And enabling sampling for varied outcomes. Top underscore K parameter, again, I'm keeping as 10. Consider the top 10 tokens at each step for a diverse response. Okay, let's see what the output would be. So once the description says every action has an equal and opposite reaction, the result is so on. The principle is the Newton's first law of motion. So these are the different tasks that we can use, we can do, using LLMs, using GenAI. Here I have utilized the Hugging Face model Falcon, which was trained on 7 billion parameters. You can look for other LLMs, other open source models present on Hugging Face, and continue with the same tasks. So thank you so much for joining in, guys. And maybe over the next few sessions, next few webinars, we'll continue discussing a lot of potential tasks that we can accomplish using GenAI and the large language models which are available to us. Make sure when you're running such code that you're always connected to a GPU for a faster processing. Thank you so much.